My name is Danko Emmanuel Kenji, and I officially welcome you to Ken Tech 96 TV. In today's lesson, we are going to talk about an electric circuit. So we'll be looking at the various components of an electrical circuit, how to practically design an electrical circuit. Then we look at how to also represent the components with their respective symbols. An electric circuit is a closed loop or path through which electric current flows. Now, when we talk of current is the rate at which electric charges flow through a conductor. So whenever you have a conductor, it has the capacity to allow the transfer of electric current and heat. So basically, this conductor has what we call free electrons. These free electrons carry what we call a negative charge. So when these electrons move, the negative charge as well moves with respect to a specific time. So if you have now if you want to calculate current, basically you have to know the number of charges which is flowing within a specific period of time. So that if you want to calculate current will be equal to the charge over time. Now electric charge is measured in coulombs with unit of C. Then time is measured in seconds. So we can have coulomb per second. So that is the unit of electric current or ampere. So in simpler terms, anytime you are asked to calculate for current, you can use what we call ampere. Now let's look at the component of an electric circuit. So electric circuit is made up of various components, and these are some of the components of an electric circuit. We have one, the active elements, passive elements, protective devices, control elements, and loads. So these are the components of what an electric circuit. So let's take them one after the other. So if you have a circuit, the active element is supposed to provide the circuit with the needed energy. That is the needed electromotive force needed to drive current. So here, examples of active elements, we can have a voltage source. We can also have what we call current source. You can have a transistor. So the voltage source is to provide electromotive force needed to produce what? Current. Now the current source, if you have what the current source in a circuit, the basic function of the current source is to provide constant current irrespective of the load. Then you have what a transistor, which is a three-terminal device, which is used for amplification of electronic signals. Then when we talk of passive elements, these elements are in a circuit. They do not either generate or they do not generate electrical energy. But what they do is that they either consume, absorb, or dissipate this electrical energy. So examples of passive elements in a circuit, we can have one, a capacitor, which is used to store charges. Can have inductor, which is also used to store energy in the magnetic component when current flows. Then we can also have a resistor, which is used to impede the flow of electric current. So if you want to impede the flow of electric current, you can use what we call a resistor. Then we also have what? A diode. Now this diode allows for current to flow in one direction. Then finally we can have a transformer here. Now a transformer can play the role of active or passive, but most of the times we consider a transformer as a passive element, and they are used to either regulate the voltage level, that is to step up and down voltages. Then number 3, protective devices. Now then we also have the protective devices, as the name indicates, protective. So these protective devices are used to protect all the electrical appliances which are connected to the electrical circuit. And here, examples of protective devices, we can have a fuse, which is made up of a metal strip or a wire, and it has its maximum breaking point. So when the current exceeds the maximum breaking point of this fuse, the wire melts, which breaks down the circuit into two and prevents the current from flowing to our electrical appliances. Then we have a circuit breaker, which is also a protective device. Then we have a relay. Now this relay works as a sensor. It senses fault or overcurrent and sends the command to the circuit breaker to operate. So the operation of the circuit breaker is based on the relay. So it is the relay that initiates the command as to whether the circuit breaker should trip or not. Now the tripping it is always set to on. So if the relay sends a command to the circuit breaker that there is overcurrent in the circuit, then this relay will trip, preventing the fault current to enter through our electrical appliances. Then we can also have, in a complex electrical circuit, we can have an isolator. This is to isolate the circuit. So if there is fault, we can isolate the faulted parts from the circuit to allow maintenance work to be done on the electrical network. Then we have the control element. Now this control element has to do with what? You controlling the circuit. So one controlling element is the key or switch. So we can use the key or switch to control the circuit as to whether to close or open the circuit. So when the circuit is closed, it means that we are allowing the transfer of what? Current from the active source to all the electrical elements. But if the key is off, it means that current will not be able to flow through the circuit. Then finally, we have what we call electrical loads. Now, a load is any electrical appliance that consumes electrical energy. So all the electrical appliances in your house that are connected to the electrical network is what we call a load. So examples of load, we can have a fridge, television, microwave, electric iron, electric kettle, air conditioning. These are all electrical loads because they are connected to the electrical network to consume the energy which is generated. So in designing an electric circuit, now these components need to be represented with their symbols. So we are going to learn the symbols of each of the electrical components. So let's start with the passive element. Remember, we said the passive element do not generate energy, either absorb or dissipate what? This electrical power or the energy which is generated. An example, the first one is this resistor. So this is the symbol of a resistor. So in our circuit, we are going to represent resistor as either this or this. Now, this is a fixed resistor. We also have this type of resistor. This is what we call a variable resistor. Then, if you want to represent an inductor with this symbol, definitely we are going to use this to represent an inductor. Then, capacitor, which is used to store the electric charge. So this is a capacitor. Then diode. So we can represent this as a diode. Then let's look at the active element. The element which is providing energy in our circuit. So when we talk of a voltage source, we are going to use this. So this is a cell. And this is also a battery. And these are DC sources, but for AC sources, AC voltage sources, we are going to use this. So this is DC voltage source, and this is AC voltage source. Then current source. I'm basically going to use this as our current source. Then the protective devices. Let's look at the symbol for fuse. So this is the symbol for fuse. Let's look at circuit breaker. And this is circuit breaker. You can indicate circuit breaker. Then the controlling devices. Controlling devices. You can have the key or switch. And this is how to represent the key or switch, which is to either close or open the circuit. You can also look at the transformer, which can either be a passive or active component. So this is how to represent a transformer. So you can use this. So this is to represent the transformer. The primary one is and the secondary one is, which is to control the, which is used to regulate the voltage levels. So on the board is what we call a simple electrical circuit. So we are trying to use the symbols of this component to draw a simple electric circuit. So this you are seeing here is the voltage source. And this voltage source is DC. DC means direct current. So this voltage source is what is going to produce the electromotive force to drive the current. So this is current. Now, this is a resistor R1 and R2, which are connected in what? Series. And the function of this resistor is what? Impede the flow of what? This current. So here we have what we call resistors here. Then to either close or open the circuit, that is to either on or off the circuit, we have the controlling device here, which is the switch or key. Then the fuse is connected here. So we have the fuse here to protect the electrical appliances. And this thing you are seeing here is what we call the symbol for electric bulb. What you see in your house for this electric bulb. So this is the load. So this is what is consuming the current which is produced by this voltage source. And this is the fuse which is protecting this electrical appliances, which is the bulb. Thank you for watching Kentech 9060. Please, if you are new to this channel, kindly subscribe for more updates. So in our next episode, we'll be looking at what we call series and power resistors. We want to learn how to connect resistors. Thank you.